Okay, let's begin. So first and foremost, welcome everyone. Thank you for spending your Tuesday night doing revision with me. Okay, before I begin with the slides, this is just how the revision kit will look like if you download it. At the front is all the promo materials with regards to the admin matters and tuition, all those. Okay, the notes will be found below over here. Okay, so whatever I cover in the slide is just a more detailed version in addition to the revision kit. Okay. Okay, let's begin. So quick introduction. I think most of you all have attended the combined chemistry revision session. So my name is Shannon. I'm an NTU graduate with a chemistry degree. I was a lab teaching assistant in NTU for year 1 students. I've been teaching for 7 years and tutoring for 4 years. I started my teaching journey as a music teacher in a music school. And then I went to teach tutoring as well after that. Okay, so I continued this path because I found joy and purpose in helping students succeed. I think it is really very nice when you see students achieving B's and A after they, or initially when they scored E8, F9, that kind of grade. Yeah, I think that's very fulfilling. That's why I continued this path. Okay. So I'll be going through 4 chapters today mainly. First one will be kinematics, followed by forces, moments, and then energy, work, and power. Let's go with the first one, kinematics. Okay, before I begin, I just want to clarify some basic concepts between a scalar and a vector. A scalar only has a magnitude, while a vector has a while a vector has a magnitude and a direction involved. So an example of a scalar would be distance. An example of a vector would be displacement. Okay, so let's try to understand the difference between distance and displacement over here. Let's say if I have this as my starting point and I move 5 meters to the right and I end up here. My distance will be 5 meter. My displacement will also be 5 meter. Let's say for the second scenario, if I move 5 meters to the left, my distance is 5 meters, but now my displacement is negative 5 meters. Okay, so for vectors, there is a plus and minus sign, and that plus and minus sign will indicate the direction. Usually, we indicate plus for the right side or forward direction, and minus for the left side or backward direction. Okay, so let's look at a few more examples. Okay, over here, let's say my starting point is here. I move 5 meters to the left, and then I walk backwards 2 meters. The distance that I traveled for this whole journey is 7 meters, 5 plus 2, but my displacement is only 3 meters. Displacement is how far am I from my starting point, which is just this over here, 3 meters to the right. Okay, hopefully you can understand this difference between distance and displacement. Let's look at another example. Now I move 3 meters to the right, and then I move 5 meters to the left. My total distance covered will be 8 meters. Distance is a scalar, it doesn't account for direction. But displacement is a vector, it accounts for direction. So it's plus 3 minus 5. My displacement is minus 2 meter. Okay, hopefully that is clear. Now let's talk about speed. Speed refers to the change in distance per unit time or rate of change of distance. Okay, so all this orange font over here means you kind of need to memorize a little bit because there's a chance that they will test this definition. Okay, so some definition you will realize that I will not put in orange. That is just for understanding purposes. But for those in orange font, you may be tested during exams. Okay, for the definition. Speed is a scalar. It only involves the magnitude. It doesn't account for the direction. If I move like that, it's 20 meter per second. If I move towards the left, it's also 20 meter per second, for example. The formula for speed should be covered in lower secondary math and even in primary school. Speed equals distance over time. So same formula. Average speed equals total distance divided by total time. All this should be covered previously as well. Now let's go to velocity. Velocity is the vector form of speed. Okay, so you can think of it as still speed, but now it has a direction involved. So if I move towards the right, it will be 20 meter per second positive. If I'm traveling towards the left in the backward direction, it will be negative 20 meter per second. Okay, so that's why I went through the displacement and distance difference first, so you can understand this speed and velocity difference. So velocity over here is a vector. It has a magnitude and a direction. The formula is very similar. Just replace your v, okay, I mean your speed with velocity, and your distance over here, right, is now replaced with displacement. So take note. Okay, and then this will be speed. Okay, and as shown in the previous example, positive velocity 20 meters per second towards the right forward direction. If I'm moving in the opposite direction, that will be 20 meters per second, but it has a negative sign. Okay, maybe I should change to it. Sorry, it's a bit hard to see. Okay. Okay, then now let's go to the third term, acceleration. Acceleration refers to the rate of change of velocity. The SI units will be meter per second squared. So first, let's try to understand why is the units like that. Okay, acceleration actually means is your speed changing or not. If there's a change in speed, there will be acceleration. Okay, I can break these units up into two parts. Okay, so like that. Okay, hopefully it makes sense. The top part is what? The top part is my speed. Okay, how is my speed changing per unit time? That will give me the units for acceleration, or that's what acceleration is about. And then we have the formula to calculate acceleration. A equals final velocity minus initial velocity. F stands for final, I stands for initial. I like to annotate that to remind myself. Okay, and T over here represents time. As mentioned just now, your acceleration will change when velocity or speed and direction changes. Okay, so for simplicity's sake, right, for combined size, we will just use velocity and speed more or less interchangeably. Okay, for pure, then they need to know the difference more distinctively. Okay. Then acceleration of free fall is approximately 10 meter per second square. What does free fall mean? So I have an object falling, right? And the only force acting on it is the weight of the object, or the only force on the object is the gravitational force. That's what I consider as free fall. And it will accelerate towards the earth, or you'll fall towards the earth at a speed of 10 meter per second approximately. Okay. So let's try to understand acceleration by looking at some numbers over here. So let's say in the first second, I'm traveling at 5 meter per second. And then in the second, I'm traveling at 10 meter per second. So my speed changed by how much? Or my velocity changed by how much? By 5. Right? In the third second, my speed is 15 meter per second. My speed increased by 5 meter per second. So what can I say about this? The velocity of the car increases by 5 meter per second every second. Hence, the acceleration is 5 meter per second squared. Okay, my speed is changing by 5 meter per second every second. That's what acceleration is. Okay, let's look at the other example over here. My speed is decreasing by 10 over here, meter per second every second. My acceleration is negative 10 meter per second squared. Acceleration is also a vector. Okay, so there's a plus and minus kind of thing to it as well. But then the deceleration will be 10 meter per second squared, because D already implies negative. So when exam questions ask you deceleration, right, it should be positive already. Do not include the negative sign. Because if you include a negative sign here, then this D over here is like a double negative. Okay, so you need to see what is the question asking. If they're asking for acceleration, it can be positive or negative. But if they're asking for deceleration, it should be positive only. Yes, this recording will be uploaded. Okay. And then I have non-uniform acceleration over here. So just now we can see that the acceleration is constant. My speed is changing by 5 over here. My speed is changing by negative 10 over here. It's constant, right? Plus 5, minus 10, minus 10. That's what we call uniform acceleration. But your speed can also change non-uniformly. Okay, as such. So let's say in the first second, I'm traveling at 5 meter per second. In the next second, 10 meter per second, so on and so forth, you can see that my speed, okay, the change in speed is not consistent anymore. So my change in velocity is not the same every second over here, and that's what we call non-uniform acceleration. Okay, and then how does that? Yes, we are reaching the graph part. Okay, so before I go to the speed time graph, let's look at the distance time graph, the simpler one first. Okay, so I have broken this into 4 different regions, as you can see over here. So let's look at the first region from T0 to T4. You can see that the gradient is constant. Okay, what do I mean by gradient? Gradient means the steepness of the slope. Okay, steepness of the slope. It's not changing, right? Therefore, my object is moving at constant speed. The gradient for a distance time graph, a distance time graph, is the speed. Okay, so that's something that you need to know as well, commonly tested in exam. I repeat again, the gradient for a distance time graph is the speed. Okay, so since the gradient over here is constant, the speed is constant. Okay, so let me bring you to the revision kit over here. So I think the revision kit over here is more concise. Okay, I have included the gradient as well. So hopefully you can see the keywords, how it links. Gradient is constant, so my speed is constant. Okay, over here I also included the gradient of a distance time graph represents speed. Okay, but over here in the slides I have to break it down lah. Okay, into the different regions because no space. Okay, let's go and look at the next one. From T4 to T6, over here, my distance is not changing. When you see a flat line, it means the gradient is 0. Hence, my object is stationary or at rest, not moving. So these are the keywords that you need to describe the motion of the object. Okay. Okay, let me just post the link to the revision kit again. Okay. Okay, next in the third region, from T6 to T10 over here, my gradient is increasing. Remember what I said about gradient? Gradient is the steepness of the slope. Okay, hopefully you can see. My slope is getting steeper and steeper. Therefore, my gradient is increasing. And what is my gradient? My gradient is the speed, right? Therefore, the object is moving at increasing speed. Okay. From T10 to T14, the gradient is decreasing. Hopefully you can see that the slope is getting more gentle. Okay, it's getting more gentle and then eventually it flattens out. Hence my object is moving at decreasing speed. Hopefully you can see how the keyword match. And what's my gradient? My gradient is speed. Okay, now let's look at the harder one, speed time graph. Okay. Okay, there's a lot of regions over here. So T0 to T2 over here. What does my gradient represent now? For a speed time graph, the gradient represents acceleration. Okay, let's use that. The gradient represents acceleration for a speed time graph. My gradient is constant, steepness of slope is constant. Therefore, my object is moving with constant acceleration. Okay, the slides are still the same. Are you able to see the speed time graph? Okay, someone commented that the slide did not change. Are you able to see the speed time graph? From T0 to T2. Is it correct? Okay, if anything.
Yeah, I can see.
Okay, okay. Yep, thanks. Okay, the gradient is constant as mentioned, steepness is constant, therefore object moving at constant acceleration. Okay, the graph is the same, the only thing that is changing is on the right, so take note. Okay, now let's look at t equals 2 to t equals 4. My gradient is 0, flat line. What does that mean? My speed is constant, no acceleration. My speed is not changing. Okay. Next, T4 to T6. Now I'm over here. You can see that the gradient is increasing. It's getting steeper and steeper. Therefore, my acceleration is increasing. Okay, increasing acceleration. And then over here, my acceleration is decreasing. Okay, because my gradient is decreasing, my slope steepness is getting more gentle. It's decreasing. Therefore, object is moving with decreasing acceleration. Okay, so for the first part, it's going upwards, right? So it's positive acceleration. When the slope is going downwards, that is negative acceleration, and then we call it deceleration as well. Okay, so let's look at the second half. T equals 8 to T equals 10. I'm over here now. Okay, hopefully you all can see my slope is getting more steeper. Therefore, gradient is increasing. My object is moving with increasing deceleration. Now my slope is going down already, so deceleration. Okay. And then over here, my slope is getting more gentle. Therefore, gradient decreasing. My object is moving with decreasing deceleration. And then the last one, T12 to T14. My gradient is constant. Object is moving with constant deceleration. And then there is another part because I don't have space. So if you see the graph being drawn over here along the x-axis, that means the object is stationary or not moving. If you look at your y-axis, right, at this point my y equals 0 or my speed equals to 0. That means my object is not moving or stationary. In contrast with this, okay, both are flat line. There's no acceleration for both cases, over here and over here. But the difference is that at this point, there is still certain speed, just that it's constant speed. But at this point, at the end, okay, my speed is 0 already. I'm not moving. So take note of the difference. Okay, let's go to forces. Forces are... Okay, wait, before I go on, any questions for the first chapter? Is it okay? Okay, no questions. Let's go on. Okay, forces are vectors. They have a magnitude and a direction. The SI unit for forces will be Newton. A force can cause an object to move, slow down, speed up, change direction, or even an object to turn. Okay, some examples of contact forces include normal reaction, friction, and tension. Normal reaction is like when you put something on the table, right? Okay, the object exerts a weight, but the table will push the object upwards. Okay, and we call this the normal force. And the normal force will always be perpendicular to the surface. Okay, so let's say if I have another example over here. So let's say I have an object like that, right? Okay, now I got incline, now there's a slope. My weight is still downwards, but my normal force, remember, has to be perpendicular to the surface. Okay, so just take note of that. Some examples of non-contact force means doesn't require physical contact. It's gravitational force, electric force, and magnetic force. What does contact forces? Oh yeah. So contact forces means require physical contact. For friction to happen, there needs to be physical contact, right? Rubbing against each other. Okay, for normal reaction, just now as I draw in the diagram as well, the thing needs to have physical contact. The object and the table or the ramp, there needs to be physical contact. The two objects need to be touching each other. Right, for gravitational force, right, you don't need physical contact. It applies to everything, even if it's something that is floating in the air. Okay, magnets also. Okay. Okay, over here I won't go through how to draw a vector diagram specifically, but generally there's two different methods, the parallelogram method and tip-to-tail method. Okay, I will just go through some exam marking points and common mistakes for this. So for the parallelogram method, the opposite parallel lines have to be dotted. Okay, this one, common mistake and commonly marked down as well. And for a tip to tail method, the tip of one vector, let's say this one, okay, the tip of one vector, the head, should be connected to the tail of the other vector. Can you see the tail of the other vector? The second one over here is connected to the head, the arrow head of the first vector. Okay, so up to you which one you want to use in exam, but usually exam questions will kind of restrict you, and parallelogram method is the more common one. Okay, but just be open to both. Okay, for both kind of diagrams, ensure that the vectors are clearly labeled. Your magnitude of forces, angles, direction of vector, all these arrows need to be shown and drawn. Okay, whatever information the exam give you, like maybe this is 30 degrees, all this, and maybe this is 50 newtons, 60 newton, label all those down. Okay, and also common mistake, or commonly forgot, not mistake. Resultant force should have double arrow, as shown over here. Okay. There is another kind of vector diagram. So on the previous slide, there was vector diagram for resultant force. Okay, and then I have a vector diagram for an object in equilibrium. Equilibrium can kind of think as equal, right? So an object that is stationary. And the vectors will form a closed triangle as such. As you can see, the vectors form a closed triangle. Go like that, then like that, then like that. Okay, so it's like that, then like that, then like that. Okay, wait, sorry. Hopefully you can see the closed triangle. Okay, this is for objects that are stationary or in equilibrium, means not moving. So means the resultant force for this object is 0. That's why it doesn't move, it stays there. Okay, if there's a resultant force, then the object will start to move already. Okay. Then Newton's first law involving balance forces. So just now I also drew this diagram over here. Because the weight and normal force, they cancel each other out, there is zero resultant force. And if there's zero resultant force, your object will not move. It remains at rest or stationary. Okay, so that's what Newton's first law is trying to say. An object will remain at rest unless there is a resultant force. This is for your first example over here. Similarly, an object will continue moving at constant speed unless there is a resultant force. So this is usually the one that students often struggle. In this case, when my F equals to R, okay, my forward force equals to R, okay, the car will still continue to move. It will not stop. Okay, but this is the scenario that is already moving. The car is already moving. Your driving force equals to the air resistance, friction, or whatever, or the resistive force. Okay, the car will continue to move at constant speed. It will not stop. So there's these two scenarios that you need to be aware of. In both scenarios, there is no acceleration or no resultant force. Okay. Then we look at a case where there is unbalanced forces. When a resultant force acts on an object, the object will accelerate in that direction of the resultant force. And you have this formula over here. I made it very big. Okay, the product of the mass and acceleration of the object gives the resultant force. So resultant force means I consider all the force acting on the object. So for example, if someone push this box 10 newtons to the right, then another guy push 5 newtons to the left, what's my resultant force? 10 minus 5 equals 5. This is my resultant force. Okay, that's what I mean by resultant force. Okay. So over here, this formula is actually related to the first law as well. Just now when I said if there is no resultant force, if this is 0, right? What does it mean? It means my object will not accelerate. If my object will not accelerate means what? It will not change its speed, it will not change its direction. So it will stay stationary or remain at rest, or it will continue to move at constant speed if it's already moving. My mass cannot be 0, right? Therefore, my acceleration has to be 0. Hopefully, you can see how this formula ties the first law and second law. Okay, they're kind of related. So actually don't need double memorize. Revision package is here. Okay. Oh wait, sorry. Oops, sorry. Let me put this. The link is here. Okay. Someone asked what is normal force. Okay, so normal force will be present if there is an object resting on a surface. This normal force will always be perpendicular to the surface. Yeah. Okay, so that's what normal force is. Normal in physics is kind of like 90 degrees. You will see normal if you do the light chapter already. Okay, in physics, normal kind of means 90 degrees. That's why. Okay. Is there any other questions? Okay. Okay, so let's look at some application of this. What if my forward force is greater than my resistive force? Okay, F is greater than R. My car will accelerate in the forward direction. Okay, so let's use some numbers. Okay, let's say my forward force is 5,000 newtons. My resistive force, let's say, is 2,000 newtons. According to the formula, right? Fr equals ma. What is my resultant force? 5,000 newtons minus 2,000 newtons. 3,000 newtons to the right. Okay, let's say my mass of this car is 100 kg. Okay, my acceleration 2 will be 30 meter per second. And this positive acceleration, right? It means that the car will accelerate towards the right or forward direction. Okay, what about the opposite scenario? If my forward force is lesser than my resistive force, my car will decelerate and start to slow down. Imagine someone pushing the car towards the left and that guy is stronger than the, so let's say I have two person here, right? So let's say now this guy is stronger, is pushing the car towards the left and is much stronger compared to the guy pushing the car towards the right. How will the car move? The car will move towards the left, right? So similar, okay? Yep, the car will decelerate and start to slow down. Why when R is greater than F? Okay, let me see. Why when R is greater than F? Okay, it has to slow down first before it begins moving backwards. Yeah. Okay. Because it's already there's still something pushing it towards the right. Right? It's not that it's totally like this force is totally gone. So example, right? Let's say I don't have this. This is not there anymore. And then someone is just pushing the car towards the left. Then the car will move backwards. But the thing is, now there is still a forward force. So like there is still a force moving towards the right, and there's still a force moving towards the left. But now the backward force is stronger, so it slows down. Okay. Okay. Now we are at moments. Any other? Why do you need to take the force minus R and not just use force? Okay, remember for this formula, I intentionally write R over here. R means resultant. When we use this formula, we need to consider the resultant force, means all the forces that is acting on the object. Okay, it's not just take any force. We need to consider all the forces. Fr equals applied minus friction. Usually, yes. The resultant force, it really depends on the context of the question. In this case, I made it very simple. There's only two forces, right? So how do I find the resultant force? I simply take the forward force minus the resistive force. So let's use numbers again. Okay, so in this scenario, let's say my resistive force is greater than my forward force. Okay, MA. My resultant force will be 3,000 newtons towards the left. And remember, force is a vector. Okay, force is a vector, and the car has certain mass, right? Okay, let's say 100 kg again. Let's remove the units over here. Okay, then if I were to calculate my A, my car will decelerate at 30 meter per second every second. Okay, the speed of the car will decrease by 13 meter per second every second. It will start to slow down. Okay, so in this case, there's only two forces we need to consider to calculate the net force or the resultant force. Sometimes they will give you more. Then you just calculate I can have air resistance also maybe. Yeah, it really depends on the context of the question, but usually, yeah, this is the case lah. Okay. Any other questions for that before we go into moments? Okay. Moments. Okay, moments over here, this definition not really required to memorize. That's why I didn't make it orange. The moment can be easily understood as turning effect of a force. A force can cause something to turn, right? About a point is the product of the force F and the perpendicular distance d from the pivot to the line of action of the force. Simply put, if I translate this English into formula, moment equals force times perpendicular distance. Okay, so I have this example on the left, which is the more straightforward one that you usually see. This is my force. Weight is also a force. Okay, and this is the perpendicular distance between the pivot and line of action of the weight, in this case, or the force. Therefore, to calculate the moment of this, I simply take 60 times 30 and give me this. But take note of the units. This is Newton cm. So sometimes question will give you in meter, so just take note of the units before you throw it into the formula. Okay, and this object over here will cause this lever to turn anti-clockwise. So for moments, we need to know anti-clockwise and clockwise. Right? If I place an object over here with a certain mass, the weight will cause this thing to turn anti-clockwise. Okay, but let's say if I don't have this, I remove this and I transfer over here, then the weight is over here, it will cause this lever to turn clockwise. Physical moments. Yep, correct. That will be covered in the next slide. Okay, but here's the more challenging example. You realize that they give you a lot of distance. So which one do you use, right? So I want to highlight this perpendicular distance over here. Okay, in this exam question, they are asking you which distance should you use to calculate the moment for this force over here. Okay, so go and identify where is the perpendicular distance. The perpendicular distance from the pivot, this is the pivot, should be from here to here. I should use the 4 meter. Don't get distracted by the 5 and 3 meter. Okay, so for the example on the left is very straightforward. This is the perpendicular distance. Right, but sometimes harder exam questions, you need to visualize and go and find where is my perpendicular distance. Okay. Yep. And principle of moments. It states that when an object is in equilibrium, means balance or stationary, the sum of the anti-clockwise moment about a pivot is equal to the sum of clockwise moments about the same pivot. So this one in terms of trend, one of the highest, very commonly tested. Please go and study. Okay. Later I will give you, later I will say what's the other commonly tested one. There's two lah. This one very high chance. Okay, in terms of trend. So let's say I have this example over here. I have a seesaw, I have this girl, I have this brother, right? So for exam questions, they usually like to ask, calculate the weight of the brother. Okay, so the weight is the unknown over here lah. So I need to apply the principle of moments to solve this kind of question. Okay, so first, I state the principle of moments. Anti-clockwise moment equal clockwise moment. Which one will cause anti-clockwise moment or cause the thing to turn anti-clockwise? It's the girl. When the girl sits here, this thing will turn anti-clockwise, right? So I calculate the anti-clockwise moment for the girl is 500 times 0.78. Okay, this is for the girl. 500 multiplied by 0.78. What about the brother? The brother will cause a clockwise moment. 1.2 times W. Okay, so for physics, you need to get used to working with algebra as well. This is your set 1 algebra, solving linear equations. Imagine this is x. I ask you to find x, right? So in this case, your W is 325 if you were to calculate it out. If you don't like this thing on the right, you can always rewrite it and shift it first. Okay. Then you want to find 1W, right? You calculate this and then you just divide the answer by 1.2. Okay, I divide by 1.2, I can get 1 unit, right? What's the question? 325. Yep, nice. Okay. Okay, another common exam question. State and explain what will happen to the seesaw if the girl moves 0.10 meter closer to the pivot. If she moves closer to the pivot, the anti-clockwise moment generated will be lower or decrease, and the clockwise moment will be greater. Okay, so clockwise moment greater than anti-clockwise. Therefore what? The seesaw will turn clockwise lor. Right? So they need to see this. This is the state. You need to write the first one for the explanation. Okay. State what happened to the seesaw. The seesaw will tilt clockwise. Why does it tilt clockwise? Because the clockwise moment is greater than the anti-clockwise moment. Okay, next commonly tested exam question. Assuming that the seesaw is uniform, explain why the weight of the seesaw does not cause a turning effect. Okay, the seesaw is uniform, right? Means what? The center of gravity or where the weight of the seesaw will be is at the center. Okay, the weight is over here. So because the perpendicular distance between the line of action of the weight and the seesaw is 0, therefore there is no moment generated. Okay, are you able to understand this? Okay. Oops. Okay, there's no perpendicular distance, right? There's no distance. So moment equals force times distance. Yes, my force is the weight. The seesaw has some weight, but the distance is 0. Anything times 0 is 0. No moment means there is no turning effect by the weight of the seesaw. Yep. Point through which the entire weight. Yep, that one also commonly tested. Okay, next one. Center of gravity. As stated by John, a point through which the whole weight of the object appears to act. For an object with regular shape and uniform density means made of the same material, the center of gravity will be found at the geometrical center. Okay, so these are some examples. This is what geometrical center means. So it is possible that the center of gravity of an object lies outside the object in the case of this ring. Okay, the center of gravity is here. Okay, it's where majority of the mass will be or where the weight of the object appears to act. Okay, so commonly tested. So this one I'll rank third. Okay, so first, in terms of trend, principle of moments, for center of gravity, third. Later I'll mention the second one. Okay, I'll rank these 3 commonly tested definition. Using a plumb line to determine... Yep, for irregular shapes, you use the plumb line experiment. Not sure how many of you have done it. Right, you just let the thing hang there, then use a ruler, draw the line. Right, then you find the center of gravity. It's where all the lines intersect at a certain point. Right, that one. Okay, but I won't be going through that today. Okay, then stability. Stability refers to an object's ability to return to its original position after being displaced slightly. Okay, if something is stable, it will return to its original position if you displace it slightly. The stability of an object can be increased by increasing the base area, having a wider base area, and lowering the center of gravity. Okay, So if you see anyone trying to push you or tackling you, right, the moment you kind of squat down, make yourself bigger, you actually will have greater balance. You won't like get pushed down so easily. Okay, I'm not sure how many of y'all watch Squid Game. Squid Game, the traffic light game, right? The first stage, you realize that a lot of the actors, they are in squatting position. Why? Because it gives them greater stability. Okay. Then sports also. Sometimes to prevent people getting pushed down. No, to prevent like how to say. Sometimes in sport, right, it's a physical contact kind of game. Right, to increase your stability, some people will actually like bend down even more, right, and start squatting down to increase their stability. So when people push them, they are more stable, they will not fall down that easily. Okay, usually basketball, that kind lah. Okay. Over here, I have a common exam question. So this is how they can test whether you understand this concept or not. Okay, which of this object is the least stable? Which of this object is the most stable? So I use these two checkpoints. Okay, so this is the least stable. The base area over here is one of the smallest. And where will the center of gravity be? Most of the mass of the object is located at the top. It has a high center of gravity. Right? I mean, this one can kind of use logic also, right? If you push all these four cups, which one do you think is the most easily toppled? Right? It will be B. And which one will be the most stable? It will be D. It has the widest base area and it has a low center of gravity. Most of the mass, right, can be found somewhere around here. So this is how they can test this. Is the center of gravity usually the biggest? Cannot assume. So to find where the center of gravity is, we need to consider where is majority of the mass at. Yeah. Can because center of gravity is defined as where the weight of the object will appear to act. Yeah. Yeah. So remember to check these 2 points individually to not mix them up. It's two different things. Okay. Okay, then I have the 3 different types of equilibrium. For this, yes, I know it looks very complicated, but what you need to know is how to identify the 3 different types of equilibrium. Okay, so let's look at the first one, stable equilibrium. Okay, this red line over here, hopefully you all can see. Okay, when I displace this cone, right, the center of gravity is actually raised. Hopefully you can see. And what will happen to this cone? It will actually fall back down. Why does it fall back down? So just now we learned about moments, right? So this is the pivot. And there's this thing over here, the weight or the force, right? This weight over here will cause a anti-clockwise moment, causing the cone to turn anti-clockwise and go back to its original position. So this is how we identify stable equilibrium, whether the object will go back to original position or not, if you go and touch it or displace it. Okay, what about unstable equilibrium? The object will topple easily. What about neutral equilibrium? The object will remain at the new position when displaced. Okay, another way to check for neutral equilibrium, you realize that the center of gravity, right, the height does not change. Even after you displace it, go and touch it, right, the height remains the same. Okay, so over here, okay, yep, that'll be it. Let me see. So why does the object not topple? Okay, commonly tested question. So usually in the form of a vehicle on a ramp or maybe double decker bus. You all probably have seen that kind of question before. Okay, so the line of action of the weight is still within the base area. Therefore, it does not topple. But over here, you can see that the base area is so thin, right? Then the line of action of the weight is outside the base area already. That's why it will topple over. The CG lowest. What if the line of action of the weight is directly above the base area line? Would it be considered stable or unstable? Okay, so for your question, I just say, what if the line of action of the weight is directly above the base area line? Let's say use this for an example, right? This is the base area this is the line of action of the weight. Would it be considered stable or unstable? In this case, it would be unstable. How do you check for the type of equilibrium? Is this second row over here? Does it return to original position? Okay, does it topple? Does it remain at the new position when you displace it? So these are the checking points. Okay. So over here, this is the pivot, right? You can see that this line of action of the weight will cause a clockwise moment. That's why your cone will top clockwise. Okay, hopefully I answered your question. Oof. Okay, last one. Ability to do work. The SI unit will be joule. So several energy that you need to know. For potential energy, there is three different kinds: chemical, elastic, and gravitational. There will be kinetic energy, light energy, electrical energy, and thermal energy as well. So for physics, right, when you write your answer, try not to use heat anymore. I have students feedback that their teachers mark them down when they write heat, so use thermal energy. Okay, so you just check with your school teacher lah. Okay, on this. Something for you to take note. Okay, and this will rank the second commonly tested definition. Okay, principle of conservation of energy. Can be 1 mark or 2 mark depending how generous your school is. Energy cannot be created or destroyed, but can be converted from one form to another. Should be 2, I think. Okay. Total energy is total energy in why so many typo here? An isolated system remains constant or unchanged. Okay, so if it's 2 mark, try to write the second one also. Some schools require students to write the second one, but most often the first one is sufficient. So just look at your notes, okay, and see what your teacher requires you lah. But of course, if you can, try to write both. Play safe so that you can get the full 2 marks. And you have 2 formulas over here to memorize. Gravitational potential energy can be calculated as such. GPE equals mgh. Take note of all the units. Okay, for this chapter, right, work energy power, before you apply the formula, make sure that all the units are in SI units. The mass have to be kg, the height have to be in meter. Okay, usually examiners like to give you grams. This one they give you cm, they give you km. You need to convert before you apply into the formula. So just take note. Specifically for this chapter, you need to be more careful. Okay, so the moment you realize examiners testing work energy power, make sure all your units are SI unit before you apply the formula. Otherwise, you will not get the answer. Okay. Kinetic energy equals half mv square. Half m is still kg. Your velocity is meter per second. Okay, that's what this V represents. Energy is joules, right? So you can see over here. Okay, so let's look at how this is applied. So for example, a metallic pellet of mass 300 gram, you can see, right? Exam question that I took out, they give you grams. It's placed at the starting position as and rolls along the slope of the track. The initial speed of the pellet at S is 0, means it's at rest, it's not moving. Assume that there are no frictional forces acting on the pellet as it moves across the track. Take gravitational field strength as 10 meter per second squared. So you need to identify all these keywords. It's really very important because it is meant to help you. It's meant to simplify the question. Okay, because we can straight away apply principle of conservation of energy. Okay, so let's see how this works. So let's say if exam question, they will usually guide you, right? So first part, they ask you, calculate the GPE, gravitational potential energy at position S. Okay, so I apply formula mgh, I get 2.4 joules. Right, it's very straightforward, usually 2 marks. And then they ask you to calculate the kinetic energy at A. How do I calculate the kinetic energy at A? I'm not given the speed, right? But I can apply the principle of conservation of energy. Okay, so based on that, so my total energy is 2.4 joules. So let's write here, GPE equals 2.4 joules, KE not moving, so 0. What about this point? At this point, there is still certain height, so there is both GPE and KE. Okay. Then I just apply the same formula to calculate the GPE at A. I just change this to 0.3 lah, right? The height over here. The GPE at A is 0.9. Based on the conservation of energy, the total energy has to remain the same. Therefore, the KE is 2.4 minus 0.9. That will give me 1.5 joule. Okay, so that's how I apply the conservation of energy thing or the concept. Okay, so you can do this whenever you see no frictional forces, smooth slope, all those kind of keywords. It's meant to help you simplify your calculation. Yep. And as John mentioned, some schools will teach the shortcut, but I want to teach the concept first. So if you understand this, okay, you can use the shortcut as well. Hopefully you understand the shortcut. Loss in GPE equals to gain in KE. So there's actually just one step to do it. Okay, you just need to calculate the loss in GPE. So how much GPE is lost? 0.3 times 10 times 0.5, and that will be the gain in KE, 1.5 also. Right, this is solving it in one step. Okay, so see if you are comfortable with this, otherwise you can break it down like the previous slide example. Okay. Okay, then we come to work. Work done refers to the product of the force and distance moved by the object in the direction of the force. Okay, so the force have to be same, no, how to say? Okay, so the distance moved by the object have to be in the same direction as the force applied. Okay, so let's look at certain examples over here. Wait, before that. So let's say I push the box 10 newtons to the right, right? And then the box move 10 meter. So what's the work done? Force times distance moved in the direction of the force, 100 Newton meter or joules. Okay, work done unit is also joules. Work done essentially is how much energy you transfer to the object. So when I push the box, what is the energy conversion taking place? Chemical potential energy, right, that is stored inside me. I transfer it to the box and the box gain kinetic energy. That's why it started moving. Okay, so that's why work done and energy has the same unit, joules. And joules is actually Newton meter as well. But for SI, we write joules. Okay. So same thing, this is still under energy work power chapter, everything in SI units. You may wonder why I use S instead of D, because more accurately, it should be displacement. Yeah, okay, but for O-level science, they simplify it a lot. So just use distance move, okay, in the direction of the force. So in what scenarios will you not have any work done? Let me see. Can we use MJ2? Okay, let me see. We use energy to get work done. Okay, this M is milli. Milli is a prefix. It means 10 power negative 3. Yeah. So you see if the question requires to live in millijoules or not. If not, we apply or just use joules lah. Is moment distance in meters to... Okay, so someone asked, going back, sorry, backtrack a bit. Is moment distance in meter to in that case? The moment here, right? Over here, you realize it can be cm or it can be meter. SI unit for moment is actually Newton meter. Yeah, but sometimes question they will use cm lah. So that's why I say only for energy work power chapter, okay, you need to be really very strict with the units before you apply the formula. Everything has to be SI, especially for energy work power. Because I see school exam questions, they require you to write Newton cm as well. So it's not every scenario or every school will test you and require you to leave your answer in Newton meter. Sometimes they ask you to leave in Newton centimeter as well. Okay. That's why I didn't restrict or limit. Okay, only for energy work power, you need to limit yourself to SI units. Okay, so no work is done when the object did not move, when your distance is 0 lah, right? The object remain at the same position. No work is also done when the force and the distance moved is perpendicular to each other. So let's say I'm carrying something. When I'm carrying something or lifting something up, I'm applying a upward force. But when I'm walking forward, right? Can you see that these forces are perpendicular? Okay, in this case, no work is being done. That's why I particularly bolded this. The force and the distance have to be in the same direction. Mechanical joules. Can we use mechanical joules for SI for work done? Can we use mechanical joules for... What is mechanical joules? Yeah, I will get back on that later. Okay. Okay, then power. Power refers to the rate of work done or rate of energy conversion. When you see rate, it has an element of time lah, right? So you can see that time is usually in the denominator. So for power over here, you will see two formulas. For this chapter, we will be mainly dealing with work done over time. The second one over here will be mainly seen in Sec 4, but of course they can combine next time lah. Okay, so I just introduce you first. After all work done is the energy being converted or transferred to an object, right? Okay. How would the distance move in the direction of the force? Okay, so back to this. Okay. So the force is upwards, right? But the distance, right, that the person is covering is with regards to the x-axis or left to right. So because the force and the distance move, okay, rather, the distance move is not in the direction of the force. The force is upwards over here, but the distance is left to right. It's not in the same direction. Therefore, no work is being done. Okay. Okay. Okay, wait. Same thing. Restrict yourself, make sure the units are all correct. Examiners like to give prefixes, kilowatt lah, milliwatt, all this kind of thing. Okay, they like to give minutes lah, hours lah. Hopefully you all know how to convert. Okay, the units of time. Okay, so show you an example. Okay, a worker carries a bag of rice and climbs a 2-meter tall ladder in 4 seconds. Given the bag of rice has a mass of 8 kg, what is the average power used to move one bag of rice to a height of 2 meter? Okay, so a lot of information over here, but you can write the formula first. That will help you. Power equals work done over time. I have my time, 4 seconds. Right, but the problem is I don't have the work done, so I need to calculate the work done first. Previously, we learned work done equals force times distance moved in the direction of the force. Okay, so let's move this here. So I have a bag of rice over here, and this thing is 8 kg. Right, so I'm trying to lift it up to a higher height. So if I want to lift this bag of rice, I need to apply a upward force lah. Like this bag of rice is going to exert a force because it has weight, right? So if I want to lift it up, I need to match a force that cancels out this weight, right? So in this case, what is the work done? The force is actually the weight. What force do I need to apply to carry this bag of rice? Simply find the weight. What is weight? In chapter 4, weight equals mg, mass times gravitational field strength. Okay, 8 mg. And what's my distance? I'm trying to carry this rice to a height of 2 meter. Therefore, the work done is 80 times 260 Newton. Okay, let's use joules. Okay, slowly process. Now I got my work done. I simply throw inside the formula and then I will get 40 watts. Okay, over here they are kind of nice. They never make you convert any units lah. Sometimes they will give you this one in cm also. You need to change to meter. If they give you gram, you change to kg. Okay, if they give you minutes, you change to seconds. Okay, so what is the work done against gravity? The work done against gravity, you simply need to calculate the weight lah. Right? How much force do I need to lift this thing? Right? It has to be equivalent to the weight. Okay. Oh, I have right answer here actually. Okay, yep, that's it for the revision session. Before I go on, is there any questions with regards to this? Okay, no? Okay, yep. So just some admin matters for those of you that want to work with me or interested in working with me, right? The QR code to express your interest is at the top right over there. Starting date is not confirmed yet. Okay, the actual location, date and time, all this not confirmed yet. Duration will be 2 hours. Fees are as such. Everything will be listed in the promo package or the revision kit. Okay, at the top more or less. The group size will be 1 to 12 depending on the location, whether is it online, because different classroom will have different space as well. So we need to see, it varies. Yep, and there'll be limited slots available because I want to limit myself. I'm a bit overworked this year lah, and I find quite guilty lah. A lot of students want help, but I couldn't give my best. Yep, so I want to limit my students this next year. Question: millijoules is shown in the question for max GP. Is MJ now the SI unit? Management is shown in the question for max. Do you have the question? You see it in your school paper, is it? SI unit for work done is still joules. I never see mechanical joules before. What's that? Yeah, what's mechanical joules? SI unit for yeah leh. SI unit is joules, same as energy. I never see mechanical joules before. Do you see it in your notes? Okay, then you just follow what your teacher say lor. Yeah. Okay, wait keep moving on. Okay, so this is just a rough plan. I will recap the Set 3 topics for November to December. These topics usually... Okay, so why do I choose these topics, right? Because it will help your math as well, your E-math. Your E-math for Sec 4, you're actually going to learn this again and you'll be tested the same thing. Okay, and this one will help you with your algebra applying formula. So there is some overlap, the skills-wise. Okay. Okay, yep, I will go back to the questions in a bit. I'll finish this up first. Okay, so do stay around for the giveaway later. There's a Kahoot. I chose the common exam questions that you can pick up the marks easily just by looking at it for a few seconds. Okay, so hopefully can ego boost you a bit. Okay, then I will start with the Sec 4 topics in Jan to May. Okay, yep. From June to August, prelims examination, prelims preparation, and then preparing you for O levels. Yep, generally the same, but you can feel assured that I have a intention or reason for doing certain things lah. Okay, as mentioned just now, I recap these topics because it will help you in your math as well. Okay, okay, this promotion packages, you can find it in the revision kit. Just take note of the deadlines. For those of you that sign up for the early bird package, you are entitled to the end of year exam kit and you will get 3 curated notes for any 3 subjects. Okay, one of it being the subject that you sign up for. Okay, for the trial package, the slots will be released to you or the date, time, everything you will be updated when it's closer to the date lah. Okay, but you will still be entitled to 2 subjects for the curated notes. Okay, so the thing that I want to highlight is that for the early bird package, you will have priority selection for the classes and time slots. Okay, I don't want to dwell too much on this. Let's go on. Okay, so yep, revision kit QR code is over here for those that missed it. The top scorer for the Kahoot quiz will win one set of curated notes. Okay, but before I go to the Kahoot, let me address all the questions. Yeah, for any students who are interested, just indicate in the comment box at the bottom of the form. There are actually enquiries for any students. Yep, just let me know. Okay, let me address the questions first before I go to the Kahoot. Would you mind explaining the work done distance move in the direction of the force again? Okay, let me go back to work done. Okay, for work to be done, or what we consider as work, okay, the distance moved by the object have to be in the direction of the force. So in both cases, right, let me see, let's look at the no work done case. The object did not move, therefore distance is 0, therefore no work done. But what about this? I am applying an upward force, but is the distance moved, okay, in the direction of the force? It's not. The distance moved by the person is towards the right, but I'm applying a upward force. The force and the distance moved by the object is not in the same direction, assuming that he carry a constant height lah. Right? Yes, the box is traveling, but it's from left to right. It's different direction as compared to the upward force that he's applying. Is that better? Is that okay? Okay, more specifically, it's perpendicular lah. I don't want to complicate things over here because got trigo involved also actually. If you do further physics, yeah, some of you all learn trigo already, right? Okay, let's start with the Kahoot quiz. Okay, let me go and get it. Let me stop sharing first. Okay, you might want to get your calculator. Calculation should be very simple lah, if I recall. It should be like you look at it, few seconds, you know the answer kind. Hopefully you all can gain some bonus marks from this lah if it comes out in exam. Okay, got it. Okay, for those of you that have other physics question or with regards to the tuition or like advice about school, subject, JC, poly, whatever, y'all can stay back to us later as well. Okay. Let me share the sound, sound effect. Maybe 30 seconds more. Wow, someone love physics. Where that guy go? Cannot see? Okay, let me... Okay. For those... where are you? Okay, anyone cannot see the screen? Someone cannot see the screen, is it? Okay. Okay, any more? 10 seconds. 10, 9, 8, 7. Any more coming in? 6, 5, 4, 3, 2. Any more? 5, 4, 3, 2, 1. Oh, still got people coming in. Is there any more? You can type in the chat. I'll wait for you. Okay, 25. Is there 3 more? 5, 4. Why decrease by 1? Okay. Okay, I will start. I think 25 is the max. Okay, these are really very easy. First question is not physics. Okay. I think some of y'all quite sharp. You realize I put my name over here as well. In case those that missed out the first section. Okay. Okay. Nice. The distance time graph, the gradient is the speed. Speed time graph, gradient is acceleration. Okay, quite easy, right? Look at it, few seconds, you all know already. Increasing acceleration. What happened? Okay. Speed time graph, gradient acceleration, right? Can you see the slope is increasing, getting steeper over here? P to Q. Okay, Q to R, your slope is getting more gentle. It's flattening out already. So that's decreasing acceleration. Okay. Wow, everyone correct. Wow, nice, nice. Incorrect, incorrect. Okay. Not too bad, not too bad. First one is correct. Highest position, highest GPE. Lowest position on a GPE converted to KE. At this position, still have some height, right? So got both GPE and KE. Okay. Neutral equilibrium. Okay, your first answer is stable equilibrium. When I displace it, it will go back to original position. That's stable equilibrium. This is unstable. This is unstable. Remember, neutral equilibrium means the center of gravity height does not change, or it remains at a new position when I displace the object. So let's say I push this ball, right? It's going to remain at a new position, right? Okay. Okay, last three. I need some calculation here. How you all calculate so fast? Everyone tikam. Okay, let's show the media. Oh, there's no media. Okay, this one need to apply formula. Kinetic energy, half mv square equals 10,000. My mass is 200. It's already in kg, right? So I leave it. Don't need convert. Remember, energy watt power need to SI units. Half times 200, I simplify. 100. Right? V squared, algebra, right? Divide by 100 on both sides, I get 100. How to get V? I square root both sides. I will get 10. Okay? So commonly tested so this one. Working backwards. I give you the answer, you solve the unknown, you work backwards. Okay. Which quantity will not affect the total work done? Okay, work done formula. Force times distance moved in the direction of the force. Okay, let me see. Don't have time in this formula, right? So work done is not affected by the time. Okay, height is the distance. I'm lifting the box up, right? Number of boxes lifted will affect the total work done. Okay, the weight also will affect because the weight is the force. Okay. Okay. B smaller than A. Okay. Yep, most of you got it. Good. B smaller than A. My resistive force is greater. I'm already moving, right? Hence, I will decelerate. Yeah. Okay. Let's leave it as that. Okay. And that's the end. Okay. 7 out of 9, not too bad. Hopefully, y'all feel more confident after this. Okay, 8 out of 9. Hey, congrats, Rakesh. Okay. Can Rakesh PM me on... Are you there? Okay. Okay. Yep, then that will be the end of this session. Feel free to stay behind if you have questions. Okay, thanks for attending, guys.